The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, welcome to this week's episode of the Lighting Controls Podcast. We are your hosts, Ron Kuszmar and Webster Marsh, and this week we have a fantastic conversation with Steve Terry. We want to remind you all that the Lighting Controls Podcast is presented by the LCA, the Lighting Controls Association, and we'll kick it to Webster.
It's financially supported by the National Association of Innovative Lighting Distributors. And also, if you're listening to this on getagriponlighting.com, you should check out lightingcontrolspodcast.com, where you can get lighting controls news and even purchase some excellent merch, such as this mug here that I have. So thanks so much, and over to Steve. Welcome, everyone, to the Lighting Controls Podcast, where we like to talk about lighting controls specifically. I'm your host, Webster Marsh, here with my other host, Ron Kuszmar, and today we have someone very special to the emergency lighting community, Steve Terry. Steve, do you mind giving us a quick breakdown on who you are and what you do?
Sure. Thanks for inviting me to this. I appreciate it. As you said, I'm Steve Terry. I'm the Director of Standards and Industry Relations for ETC. From 2004 to 2017, I was the VP of Research and Development at ETC, responsible for global new product development. I've been active in codes and standards for nearly 40 years now. I've been a member of National Electrical Code Panel 15, which deals with the entertainment and healthcare articles of the code since 1994. And in 2021, I became a member of Code Panel 13, which deals with emergency lighting. I sit on a number of UL standards technical panels. Particularly germane to this discussion would be STP 924 for emergency lighting and power equipment, and STP 1008 for transfer equipment. In the deep dark past, in 1986, I chaired the US ITT committee that wrote the internationally accepted DMX 512 standard for digital lighting control.
Well, thank you so much for joining us today. I mean, you know, right there, you've kind of summarized a lot of why we wanted you to be on this show. And I feel as though, you know, we could dedicate multiple episodes, each one to one of those moments in history. But, you know, today we wanted to bring you on because of the heated topic of emergency lighting controls in general. You know, I feel as though lighting controls is one of those scopes that either gets missed, ignored, finger pointed, any number of things that happen with emergency lighting controls in our industry. And so I'm just curious, from somebody who is integral to generating the standards and requirements of emergency lighting controls, where do you think we are right now when it comes to emergency lighting controls?
Well, if I may, can we drop back a little bit in time or altitude?
Absolutely.
And just okay. And emergency lighting controls in the U.S. have been undergoing a significant amount of activity and change in the past, let's say, 15 years. And those changes have been driven by a number of things, but the big ones are as follows. For many years, emergency lighting was handled by unit equipment, bug eyes on the wall, and the sophistication of it was low. It basically got the job done, and everybody was satisfied with it. Then the design community began to say, whoa, wait a minute. These are ugly fixtures. We don't accept the fact that separate emergency lighting fixtures need to be used. We want the same fixtures that we're using to light the space to be part of emergency lighting. So this spawned a whole cascading series of events in terms of products hitting the market, and then changes to the code sometimes changes to the code to prohibit the products that had already appeared on the market because they weren't compliant in one way or another. So there has been a kind of a catch-up effort between three standards: the NEC, the National Electrical Code, specifically Article 700, UL 1008 for transfer equipment, and UL 924 for emergency lighting and power. And sometimes one or more of those standards has taken the lead for a cycle, and then the others have had to catch up. So I talked about the pressure from the design community to use the same luminaires for emergency as normal. There's another thing which can't be discounted, and that is the decreasing power cost of putting foot candles on the floor due to the advent of LED lighting, right?
Sure.
That basically changed the whole design of emergency lighting systems. And it spawned a level of centralized emergency lighting control that we had not seen before. And it also created a climate where emergency lighting systems are designed by specifiers, often of unique, disparate components that are assembled together in a field assembly that meets the requirements of the code and in all the codes involved, of which there are quite a few. So we've gone a long way from bug eyes on the wall with local batteries to complex centralized emergency lighting control, sometimes non-compliant, right? So, you know, I think that when I look at the number of products that, for instance, we do as a manufacturer at ETC, you know, we have a portfolio of lighting control products, and it's not huge, but it covers a lot of control areas. But we spend a lot of time answering questions from specifiers, installers, inspectors about how these systems should go together in a compliant way. So it's a very hot topic, and it's a hot topic where many specifiers are uncomfortable in this new centralized control milieu that we're dealing with, and they look to manufacturers or other experts to help them specify, right? And
sure,
so
no, and yeah, I think
ahead.
you know, one of the things that you hit on, which is really critical right now, is the uncomfortable sense that specifiers have, especially if they're just a lighting design firm. They're not actually an engineer that stamps drawings. They will fear liability and therefore say that is not within our scope. That's the engineer's responsibility. But then on layering on top of that, if they're still the designer for the lighting control system and the engineer is now doing the emergency part of that system, it's almost like you have to kind of work together to come to a design of a lighting control system that both groups have their hands on, essentially. And so
yeah,
it sounds like the manufacturer kind of becomes the glue between those two groups.
I think that's true, and it gets even more interesting when let's say we're working on a place of assembly, you know, a theater, and now we have a theatrical lighting design consultant dealing with the performance lighting systems. We have an architectural lighting consultant dealing with the bathrooms and the lobbies, perhaps, and you know, then we have the engineer who is dealing with the emergency requirements. And so you know, when you ask a question, whose job is this? You often get a lot of finger pointing, you know, well, it's really his. We don't want to do it. It's not part of our scope, right? Yep. So yeah, that that has spawned an effort, certainly on the part of many manufacturers, but at ETC, we have quite an education effort going on outreach to consultants and designers, training in a various factory sales settings to get people to understand how these systems go together. Because as we talked about, a wide variety of products coming together to create a centralized system, it means the variables and the ways that they can go together become confusing. So where to use what is an important
well, and to your point, through your digression of the history of emergency lighting controls, it's fairly recent that we're able to use the general purpose illumination for emergency as well. And because of that, there's new technology that's been introduced over the last 10 years or so that has provided that feature that's been requested. But at the same time, there's still these two standards, UL 1008 and UL 924, which are part of the requirements for meeting that emergency illumination. And it can be confusing sometimes to know which part you're providing, which standard you're trying to meet to be able to provide the emergency illumination.
Sure, and that has not been helped by activities from various manufacturers over the last 15 or plus years. And so why is that? Well, early on, I mean, let's again pull back and talk about a few components.
Sure.
One component that's been with us for a long time is the automatic load control relay, or ALCR.
Yep.
For many years, that device was never exposed as a standalone piece of equipment. It was hiding inside the bug eyes and the battery-operated unit equipment, right? And it simply has one job only: monitor normal power. When normal power goes away, bypass normal control, that is a switch or a dimmer or whatever it is, and force the Luminaire to full on. Well, in the early days, some manufacturers decided they were going to improve on this. And so they created the ALCR products, automatic load control relays, that actually operated as transfer switches. Okay, they actually took the Luminaire off of its normal power and control and transferred it to a separate emergency branch circuit.
So just to clarify here for our listeners, basically the difference between an ALCR and a transfer switch is that you're actually, in a transfer switch, you're actually changing from one circuit to another, whereas in an ALCR, you're just detecting whether or not normal power is present, and when that disappears, you're basically telling the fixture to go full.
Bypass versus transfer. This
right.
is a UL 1008 transfer switch transfers. If transfer is anywhere in the description of what the product is doing, it's a UL 1008 device. So this situation of early ALCRs providing a transfer function was unfortunately not helped, and I'm not saying this as a negative to the organization, but was not helped by our friends at UL, because UL listed these devices, these early ALCRs, under UL 924, which is emergency lighting and power equipment.
Gotcha.
And it was doing a function which it was never tested for. It didn't meet the requirements of it. So this required quite a bit of unwinding. And it happened in a very interesting sequence of events, right? We changed the National Electrical Code in Article 700 to say, this is an ALCR. This is an automatic load control relay. Here's how you can use it. And by the way, it shall not be used as transfer equipment. Okay, that was step one. Step 2 was to go into the UL 1008 standard and create a new category of product. And this is probably one of those sea change moments in terms of the cost and complexity changes in emergency lighting. Because a UL 1008 transfer switch of old is a typically feeder level device with a lot of complexity and a lot of expense. And it has one feature which drives a lot of its expense. Article 700 requires a general purpose transfer switch to be electrically operated and mechanically held. That means it's a bistable device. You tell it, go to emergency, and then you do nothing and it stays there for the next 100 years until you tell it, go to normal. And when it's stable in one switched mode or another, no relay coil is holding it there. It's a mechanical hold. And the interlocks between normal and emergency are mechanical. This means it is hugely expensive. So one of the concessions that we managed to create for a new device called the Branch Circuit Emergency Lighting Transfer Switch, or BCELTS, is that it no longer had to be mechanically held. It could be electrically operated and electrically held. It could only be used on emergency lighting loads and only up to 20 amps. And this created basically a code compliant, safe version of the transfer switches, I'm sorry, the ALCRs that were being misused as transfer switches.
Sure.
But it's still, this device had to pass what I call the diabolical tests of UL 1008. And those tests involve short circuit withstand rating, source interconnection prevention, durability, a required number of operation cycles, all the things that make it hard, because you want it to be hard. Because when a device that's transferring between normal and emergency goes wrong, a lot of bad things can happen. So this device was then created inside UL 1008. By the way, the National Electrical Code at this point knew nothing about a BCELTS. Then right on the heels of creating in UL 1008, we went and made a proposal to the NEC to create a new section, a new paragraph for branch circuit emergency lighting transfer switches. So here's an example of one standard leading the other, or in this case, a mistake in implementation, a potentially unsafe condition, driving the appearance of a new device, and that appearance of that new device then appearing in the National Electrical Code.
So, I mean, it was really just a core group of people trying to make this happen because it was an unsafe standard that was being implemented. And if UL 924, the original UL 924, hadn't been created, maybe there wouldn't have been as big of a push. Is that sort of...
Well, UL 924 has been around forever, right? It far predates the standalone automatic load control relay. You know, it covered exit signs and unit equipment, basically. So how did these changes in the code and UL 1008 happen? Because there are a bunch of us got really mad that we were playing by the rules of UL 1008 and the National Electrical Code on transfer equipment, and there were manufacturers that were not. And they had an unfair commercial advantage, and it created a potentially unsafe condition. And so that motivated us to modernize the standards to cover this or correct this interesting condition.
Well, that's really interesting to hear about because, in a lot of cases, people kind of envision people making these standards in sort of a vacuum or just sort of a panel of people saying, okay, how can we charge people more money or something like that. But I think in this case, we're really talking about an altruistic endeavor. The point of this movement was not driven by money or any kind of self-interest. It was really more to make sure that people were protected and that the right equipment was provided for the right project. And, I think that that's really heartening to hear about because, again, all these negative stories get passed around very easily, but these positive stories, we don't really hear about this very often.
Yeah, I would say, yes, there was some altruism involved here, and there was it was this annoyance at the misuse of the standards in the marketplace. But there's always money involved, right?
Well, sure.
There's always a commercial imperative involved.
Yeah. But the commercial imperative here worked hand in hand with the safety of people. So
yes, it did. And by the way, it continues, okay? It continues. I'll give you another example, deep down in the weeds of UL 1008. So some manufacturers introduced branch circuit emergency lighting transfer switches to the market. And one of the important things about a UL 1008 device that is different from a UL 924 device is that a 1008 device must have a short circuit current rating. And a manufacturer submitting the device to the lab has a number of choices about the way that they can achieve a short circuit current rating. Some of which are annoying to the end user, such as you can only connect this device to certain brands and models of circuit breakers. That doesn't go over well in the industry. Or overly expensive to the manufacturer. Like we submitted this under the test that allows this thing to survive 3 half cycles of short circuit current. Okay, we don't do that because it raises the cost of the device. So the overwhelming number of branch circuit emergency lighting transfer switches on the market right now were tested with fuses to achieve their short circuit current rating. Now, here's where it gets interesting. Some of those devices had integral fuses built into the device. Some of them did not. And various manufacturers left it up to the end user to provide the correct fuse.
Interesting.
Now, I challenge anybody, including Albert Einstein, if we could resurrect him, to go to the instruction manual on these devices and determine whether or not a fuse is required when the device is installed. The answer is a genius couldn't figure it out from the instructions. Okay? So what was the result? The branch circuit emergency lighting transfer switches were being installed without fuses in violation of their UL 1008 listing, creating a unsafe condition because without the fuse, either internal in some devices or external in others, the device does not have a short circuit current rating. So what happened? The 9th edition of UL 1008 just got published about 3 months ago, and there's a new requirement that says in the instructions and on the marking of the device, you must state that this device, this BCELTS, must use uses the word required fuses. And you have to show them as required in any drawing in the instructions. Another example of the standard evolving to catch a problem, a field problem. So,
And it's probably going to continue to evolve as more of these applications get utilized. And so, I mean, you know, it's a living document, but I think from a specifier standpoint, that does make it challenging to stay up to date on all of it because it keeps changing.
Totally. So here's another good example of evolution that didn't happen for a while. In the 2014 code, National Electrical Code, continuing in 17 and 20, a new device was introduced called the directly controlled Luminaire. Mm-hmm. What is a directly controlled Luminaire? Now it's now called a directly controlled emergency Luminaire, but that is basically any Luminaire used for emergency that has a control input. Okay. And what did the code say? It said, okay, you can use this device for emergency, but if it has a control input, the Luminaire needs to have an emergency listing, which means you got to, if you want to use, for instance, an LED Luminaire with a 0 to 10 volt input, if you're going to use it for emergency, it's got to have a UL 924 listing. So what did the manufacturing community do? With few exceptions, they completely ignored that. They said, we don't like it, so we're not going to do it.
Yeah.
Right? So there was now a dilemma. You couldn't find, for basically 6 years, you had a requirement for a directly controlled Luminaire used as emergency to have a listing for emergency, and nobody did it.
Right.
Now this brings up an interesting point though, which you know, I've heard so many debates about this one line in the requirement, and you know, I've seen volleys of emails explaining one side or the other regarding its application. But you know, one of the things that's interesting because of 0 to 10 volt is that the requirement for 0 to 10 volt almost implicitly states that it functions like an emergency Luminaire in the sense that if it gets no 0 to 10 volt input, it goes to full output.
Right. Okay. Yeah. So let me finish the story.
Yeah, go for it.
So this was a big dilemma, right? The manufacturers are saying, we're not going to do this because it's not adding any value. But what they missed was a 0 to 10 volt or a dolly emergency lighting fixture has two ways to get energized. One way is disconnect the control input. Now the fixture has no choice but to go to full. Another way is to provide an active control signal from an emergency listed control system. In this case, you have now a bunch of components that all have to work together, right? So the manufacturers said, well, we're still not going to do this. So it became clear we had to find a way to rationalize this requirement in the code, which everybody was ignoring. So in the 2023 code, just published a few weeks ago, section 700.24 on directly controlled emergency luminaires changed. And it changed, and it basically said, if you use a directly controlled emergency luminaire, it's got to have an emergency listing under UL 924. But if you energize it when normal power is lost using a listed emergency lighting control device, so the operative words being disconnect, you got to disconnect the control input, chop the wire, and use a listed emergency lighting control device. Now, the Luminaire itself does not need an emergency listing. So, if you're going to energize it using an active control signal, whether it's, you know, dolly, DMX, whatever it is, 0 to 10 volts, you need a listing, an emergency listing on that Luminaire. But if you're going to disconnect it using a listed automatic load control relay, which many ALCRs now have 0 to 10 volt or dolly relay contacts, included in them. Now the Luminaire doesn't any longer need the emergency listing.
And that's for Luminaires that would go to full if you disconnected it.
That's exactly right. And basically there was some debate about could an automatic load control relay create a situation where you went to less than full. The answer is no. Code Panel 13 spoke on this issue. Basically said there are emergency lighting control devices that will drive fixtures to less than full, but they're not automatic load control relays. They're another kind of ELCD. And now it's worth thinking about this word ELCD, and I'm going to meander a little bit, but why do we have a thing called an ELCD? What the hell is an ELCD? Emergency lighting control device. Well, okay, what is that? It's a thing, and it's a thing that it's a thing that performs some emergency lighting control function, including but not limited to A, B, C, D, E, F, and G. Where did this come from? This came from the revisions that we made to UL 924 in 2018 to accommodate equipment we haven't even thought of yet. Because for many years, UL 924 only had one kind of emergency lighting control device. It was the automatic load control relay. So everything got related to a ALCR-like function. And we didn't want to make that mistake again. We wanted to kind of open-endedly create this emergency lighting control device, define the kinds of functions that it could do, and then go from there. And this turned out to be prescient. Why? Because all of a sudden we got ambushed. Power over Ethernet jumped out of the bushes. And people said, okay, we want to use power over Ethernet systems for emergency. So look around. What in a power over Ethernet system needs to have a UL 924 listing? Well, if it's an emergency lighting control device, and that is defined as a thing, as we talked about before, which produces or performs one of these types of functions, then it needs a listing, a UL 924 listing. And by the way, this definition of an emergency lighting control device went into the 2023 code. So now, another case where UL 924 drove the definition, followed in the National Electrical Code. And so when somebody says to me now, Steve, I'm doing a power over Ethernet system and I've got some emergency lighting on it, does the Ethernet switch that's driving these devices need to have an emergency lighting listing? Answer, let's go to UL 924 and see whether it performs one of the emergency lighting functions. Oh, look, it does. So now it's clear that that Ethernet switch needs an emergency listing, right? So the fact that it's generic now, again, this, covering devices we hadn't even thought of. If I had told you 5 years ago, you're going to need an emergency listing on an Ethernet switch, you would have said, what have you been smoking, right? Yet here we are. Right? So it turned out to be a very good move to not tighten down the definition in UL 924 too tight, so that the next thing would be off in left field and we couldn't figure out whether it needed a 924 listing. And by the way, people often ask me, mostly manufacturers who don't want to do it, don't want to get an emergency listing, they often ask me, or say, well, what value does a UL 924 listing add to a device? The answer is a level of reliability that can be counted upon.
Yep.
The fact that it has to pass a voltage surge test that is, much more than a normal lighting fixture has to pass, or and it behaves in a predictable fashion, right? It's tested under all the sets of conditions that occur when normal power failure occurs. And by the way, normal power failure is never a clean event, right? It's not like, oh, the normal power goes out and the emergency power shows up and everything is wonderful, right? The power goes up and down as the power company's making corrections. There's noise on the line. So we really would like to have our emergency lighting control devices come through this okay and perform as they're supposed to, right? We don't want them to go out to lunch because they encounter something or a sequence of events that's unexpected in the loss of normal power. So,
well, and I think, by creating these standards, requiring all of these things, that must be implemented. It's not a suggestion. It's a requirement. You're basically extracting the owner's pocketbook from that conversation, because a lot of people would go, why do I need to pay this much money for something that I'm never going to use?
Yes.
And this is a key difference between things involved in emergency lighting control and every other thing involved in the lighting control system, right?
Yes.
They are life safety devices.
Yes.
And so it's too expensive now has to take a back seat, right? Because you don't get to choose. It's a life safety device. It has to do with the codes, starting with the life safety code, moving on to the National Electrical Code, moving on to product-related standards from UL. It has to comply with all of those things. So you realize that when you are designing as a specifier an emergency lighting systems, you know what? Maybe not figuring out the cheapest way to do it is not the right approach. You got to consider, hey, my family's in that facility trying to get out with no power. Is this thing going to work under all the right conditions? Or,
Yeah. So I want to circle back to the ALCRs real quick. So like you mentioned, a lot of the ALCRs have 0 to 10. So that was really easy. Now I want to jump to DMX for a second, right? So adding DMX into your system and having directly controlled luminaires that are DMX that are listed for 924. Can you tell us a little bit about that process for you guys, for how that went with the creation of the DEBC, the DMX Emergency Bypass Controller, and then getting fixtures like the color source listed for 924 to be directly controlled luminaires?
Sure. Well, first of all, we did it because we live in a DMX world, right?
Yep.
The kinds of traditional facilities and control systems that ETC produces, the primary control protocol is DMX 512. So it made logical sense for us to create these devices like the DMX Emergency Bypass Controller, which basically monitors normal power, and when normal power goes away, forces selected fixtures on the DMX 512 link to go to full. But this required, as you said, emergency lighting listings on certain fixtures, which was not onerous, okay? It did not, mainstream manufacturers refused to do it for a lot of years because they said it adds no value, it costs a lot of money, we don't want to do it. UL has a process where these devices have what is called a complementary UL 924 listing. That means they have either a UL 1573 entertainment lighting fixture listing plus a a complementary UL 924 listing, or a UL 1598 normal Luminaire listing and the 924 listing. It was neither difficult nor expensive. So, you know, I think that the advent of the changes to Section 700.24 in the 2023 code, that is the disconnection permission. If you disconnect it, it doesn't need a listing as the fixture. This is going to drive a lot of mainstream system architecture towards an ALCR disconnection method, because you know, there are just too many fixtures that designers want to use that may or may not have a UL 924 listing. So, you know, it's far simpler to abandon the idea of an active control signal being the participant in getting the fixture on when normal power is lost, and just disconnect that control signal, whether it's dolly or 0 to 10 volts. Yep. So, you know, we continue to have selected fixtures in our line be UL 924, and we will no doubt continue to do that going forward. But
well, and it's easy to disconnect the 0 to 10, right? So it's very easy to do that. It's not as easy to just disconnect DMX, right? Because that fixture is really looking for an active signal.
Yeah, and it is. It's much more of a pain to, you know, we have loss of DMX behavior settings in fixtures, yes, right? So you could tell it when DMX goes away, go to full, but do you really want that? I mean, you really want you know, whenever you do a normal shutdown on the control system, that means yes, the fixture's going to full, right? So, you know, look, the British have a great expression, horses for courses. There are certain pieces of equipment that work well in an emergency lighting system design in a certain set of conditions. In other emergency systems, it's different pieces of equipment. So, so the idea of a more passive approach in emergency lighting, disconnection of a control signal, it has some attractions. You know, now,
but I mean, to your point though, I mean, you know, it depends on the application. I mean, if you're doing a Broadway musical, you don't want your disruption of DMX to cause an unwanted illumination on that set. Right. And so you wouldn't change your DMX your personality to say go to full on loss of DMX. Right. Additionally, if you're powering down your console every single night, you don't want your stage lighting to go on to full, because then you'd have to either shut off the relays or do some other way of forcing those lights off. So, you know, in that specific application, you don't want that functionality. But if you're doing DMX in a permanent architectural setting that has you know, a routine and is constantly playing or something like that, okay, fine. You know, you can go to full in that application, especially if it's providing illumination for the egress path.
Yeah, absolutely.
But wouldn't the fixture need to be set? Wouldn't the fixture need to be set from the factory that way? Because then you're leaving it up to the end user to potentially have to, to actually set that.
Here's a very interesting, you know, concept. When we're taking a whole pile of equipment from manufacturer A, B, C, D, E, and F, and we're gluing them together in the field to create an emergency lighting system, that requires a fair amount of installer and end user savvy and AHJ inspector savvy. How are we going to test this thing to make sure it absolutely works the way it's supposed to? So this is exactly right. I mean, I just think another philosophy that I have always tried to follow with emergency lighting control systems is simpler is better. Yeah. You know, don't try not to think about the most complicated way that you can do it. think about the simplest way you can do it. And I want to just touch on one other area of the NEC, which we put in a couple of cycles ago, one cycle ago, I think, which is section 700.16b, system reliability. The wording in this, much of the wording in this section is old, and it basically covered, you can't have a situation where a light bulb burns out and a space gets put in darkness that requires emergency lighting. But now we've got these complex emergency systems with lots of components. We don't want any single point of failure to put a space in darkness, right? So 700.16b reiterates, by the way, emergency lighting control devices need to have an emergency lighting listing, because that's a minimum level of reliability. So when you take a look at the requirements of the Life Safety Code, NFPA 101, and this specific section of the NEC, it is not unreasonable to conclude that you're going to need some redundancy all the way down the system here. Don't do it with one of anything that might fail and put the space in darkness. You know, if you have two control devices, two emergency lighting fixtures covering a space or more, depending on the size of the space, that's an appropriate way to meet the code and meet the intent of an emergency lighting system, which is it's going to work every time, even if some one thing fails.
I've got an interesting question off of that point, though, which you know, I'm sure is a topic of discussion in the background. But basically, you know, you mentioned lamps burning out, and that's a pretty noticeable thing in non-LED fixtures. But in LEDs, we have luminaire depreciation over time, and while the luminaire may still energize to full, the output from that luminaire is no longer full after a period of time. And so, you know, are we going to get to a point where, you know, we have emergency illumination in spaces, but that emergency illumination no longer meets the requirements of that space because it's been used for so long?
Well, it depends how much margin the original designer built into it, into the system, right? You know, if you said, well, I can use this one luminaire, and we require 1 foot candle on the floor, and I can get to 1.05 foot candles using this one fixture, and that's what I'm going to do. Is that smart? No. I mean, basically, I think you know, how about let's have 5 foot candles on the floor? You know, I mean, you know, squeezing emergency lighting, especially since the power cost of getting those foot candles on the floor has decreased by such a tremendous amount because of LEDs.
Yep.
Yeah.
You know, there are all kinds
so I mean, I guess
of
it's really more ownership on the specifiers to make sure that that level of redundancy, that level of cushion is provided, so that, you know, 10 years, 20 years down the road, it's still a sufficient amount of illumination, you know, even if the fixture hasn't reached L70 yet.
Yeah. The, you know, the far bigger problem is there's a requirement in the codes to test these systems on a regular basis. Does it get done? No. And you know, and so that's the more interesting question.
Yeah.
When the emergency lighting is needed, is it there? And maybe it's not because it hadn't been tested for a year, you know. And of course, there are now fixtures that have built-in self-test modes, and basically report when they've tested, and, you know, very advanced building management kind of functionality, which you know, is an improvement against no testing. you know,
Right.
so that
Yeah.
is.
So, quick question, Steve, but I want Webster to answer one thing first. Webster, you mentioned L70. I'm
Yes.
just thinking not everyone listening
Yeah,
may
no,
know
that's
what
fair.
L70 is.
So L70 refers to when the Luminaire reaches 70% of its original output, and that's the recommended time to replace the fixture. And an L70 rating will say, you know, this Luminaire will go for 200,000 hours before it needs to be replaced at the L70%.
Mm-hmm.
Thank you. I thought of that and I'm like, oh,
Nope,
not
nope, good.
everyone listening may
Absolutely.
realize that. Uh, Steve, when does the 2023 NEC code actually take effect?
Well, it takes effect whenever the local municipalities around the U.S. adopt it, right? And that's
Got it.
a very wide range, right? In other words, it might be years in some localities, right? But
Yes. So it's
the
important for people to understand based on their area, their county, their state, that they need to check with the jurisdiction as to what version of the code they're using.
that is true. But my experience has always been when a major change occurs in the code and a discussion with AHJ occurs about this particular change, if the latest version of the code solves the problem, my experience has been that it's much easier discussions to say, hey, this changed in the 2023 edition. I know you're on the 2020 edition, but take a look at this, right?
Yep. Cool.
And
then
this
just
is
so everyone
Okay.
listening, because we've mentioned AHJ a couple of times, for anyone who doesn't know, AHJ is authority having jurisdiction.
generally the inspector.
Yep.
Yeah.
So we're almost out of time, but I just want to give a brief summary of all of the things we've talked about today, because I think it's all really important stuff that, you know, specifiers, whether or not you do the emergency lighting controls design or not, it's all important stuff for you to think about and be aware of. But I mean, you know, Steve, you've been a part of this very specific section of the industry for so long, and you have so much experience, and you've seen so many changes that, you know, this industry really is trying to coalesce to a much easier format of emergency lighting controls as opposed to a more complex format, which is, I think, what a lot of people perceive it to be. You know, I've spoken to a lot of engineers and people who are just sort of like, well, you know, it's a lot harder nowadays to do emergency than it used to be. And it's like, well, but that's because of, you know, all these other extra things. So really the origination of the complexity is that we want to use normal luminaires to do the emergency illumination. If we were okay with bug eyes, you know, really ugly wall mounted fixtures or ceiling mounted fixtures that provided that illumination and didn't do anything else otherwise, you know, we wouldn't be here. But because we want to use the normally operating lighting in the space to provide this emergency illumination, that's why we're here. And that's why we have all these standards that are constantly evolving, because they're trying to make sure that if we are going to be using the normally operating illumination in the space, that it's actually going to provide what people need in an emergency. And so, you know, we may see other radical changes in the future to the emergency lighting controls requirements that are out there. But the reason why that will happen is not because there's a gotcha or there's a desire to manipulate the system. It's really to make sure that there's no shortcutting the necessities of these systems. There's no back door that people can use and go, oh, well, you know, here's an ALCR, but it's not really an ALCR, or here's an emergency device that's going to provide all of your necessities and it's going to be a lot cheaper. But then, you know, the standards are going to say, no, that doesn't meet X, Y, and Z. You need to meet X, Y, and Z to be able to provide the safety of people. And so that's, again, why it's such a touchy, heated subject for people too, is because we're not talking about just the aesthetics of a space anymore. We're not talking about the general impression people has.
Yeah.
We're talking about the ability for people to leave the building under an emergency circumstance and people to respond to an emergency inside the space.
Mm-hmm. Yeah, and I think there's no sign of the evolution slowing down. And, you know, again, The 2023 code will now contain sections on Class 2 emergency lighting systems, covering, power over Ethernet and the like, right?
Mhm.
And there are now requirements for that. So, as near as I can see, every 3 years, there's going to be more requirements driven by the market requirements to do what you just said. Use normal lighting fixtures for emergency purposes in a safe way.
Well, Steve, thank you so much for joining us today. I hope our listeners got a lot out of this, because personally I did. I really enjoyed this conversation and going through all of the history of these standards. And, hopefully we'll have you back on the show. But for now, again, thank you so much for joining us.
Okay, I've enjoyed it. Thanks for inviting me.
Well, thanks everyone for listening and for watching this episode of the Lighting Controls Podcast. That was a fantastic conversation with Steve, and we just want to remind everybody that this show of the Lighting Controls Podcast is presented by the LCA, the Lighting Controls Association.
It's also financially supported by the National Association of Innovative Lighting Distributors, or NAILD. And if you're listening to this, again, on getagriponlighting.com, you should check out lightingcontrolspodcast.com, where you can check out other episodes, check out some lighting controls news, and even possibly purchase some merch like this mug over here. Thanks so much, and thank you, Steve.